Hello, everyone, again. All right, let's do test number 7, practice test number 7 for Math 107. Let's talk about it. And proceed. There's 20 problems. Let's work for it. Question number 1. It seems these days that college graduates who are employed full-time work more than 40-hour weeks. In a survey for a recent year, there were 78 respondents who were college graduates employed full-time. The reported number of hours each worked per week is summarized in the following histogram, which was displayed in a government publication. Basically, they're saying, and you'll see it when this scrolls down for everyone. You see that for number of hours worked per week, 26 to 30 hours a week, on average, in that group, there's 8 people of the 78 that are working 26 to 30 hours a week. 31 to 35 hours a week, there's 26 people doing that of the 78. 36 to 40 hours per week, 18 people of the 78 are doing that. 41 to 45 hours per week, that's 13 people doing that. And 46 to 50 hours per week, that's 8 people doing that. And 51 to 55 hours a week, there's 5 people doing that. Based on the histogram, using the midpoint of each data class, estimate the mean number of hours worked per week by these respondents. Carry your intermediate computations to at least 4 decimal places and round your answer to 1 decimal place. So based on the histogram, using the midpoint of each data class, based on the histogram, using the midpoint of each data class, estimate the mean number of hours worked per week by these respondents. So you're looking at a situation, if you're going from 26 to 30 or 25.5 to 30.5, the average comes out to be between 26 and 30. The midpoint there and the average between 26 and 30 is 28. There's 8 people working about 28 hours per week. From the 31 to 35, you could call it 30.5 to 35.5. Doesn't really matter. When you get the average there, it's going to be 33. 33 hours per week, and there are 26 people in the group of 78 doing that. As we proceed, 36 to 40, the average would be 38, and there's 18 people doing that. From 41 to 45, that gets you to 43 hours on average. Between 41 and 45, it's an average of 43. There's 13 people in that situation working that kind of work. 46 to 50, the average is 48, and there's 8 people doing that. And 51 to 55, that's 53 on average, a lot of hours. And there's 5 people doing that. Estimate the mean number of hours worked per week by these respondents. Well, again, 8 people, roughly this many hours. 26, roughly that many hours. 18, roughly that many hours. 13, roughly those hours. 8, roughly those hours. And 5. Well, what is 5 and 8? It's 13, plus 13 is 26, plus 18 is 44, plus 26 is 70, plus 8 is 78. Sounds pretty good. Tell you what, we'll do a weighted average. We'll grind those numbers and divide by 78. So what we're talking about for the mean number of hours, mean, also known as average oftentimes, depending on how you want to talk about it, that's 78. And let's grind those numbers and see where we are. Eight times 28 plus 26 times 33 plus 18 times 38 plus 13 times 43 times 8. I say times, I should not have said times. Let's see here. Okay, let's delete that. Let's delete this. Okay, 13 times 43, guys, hopefully I didn't mess this up too much. 8 times 48, 5 times 53. Okay, some pretty big numbers there. 2,974. And divide that by 78. Again, hopefully the mistake I made didn't carry too much. I got 38.1282. 38.1282 hours on average, roughly, right? So let's see here. And then they're rounded to the nearest tenth. Let's just see if we're in the ballpark to begin with here, guys. I hope I handled the calculator correctly is what I hope. Let's see what we got here. They got 38.1 hours per week. 38.1 hours per week. This is before any major round off. They want it rounded to the nearest tenth per week. And there you go. Okay, that's number one. Okay, very good. Problem number two. There are 13 students. For problem number two, there are 13 students in a certain painting class. Their ages are shown below. Complete the grouped relative frequency distribution for the data. Note that we are using a class width of 4. Write this thing out. Well, okay. I mean, that one's a little easier done than explained. They got age. This is 2. Age, relative frequency. (16 to 19). Now, why are they saying that the width, we're using a class width of 4? That sure don't look like 4. Well, go over to the left, and the 16 becomes 15.5. Go over to the right, the 19 becomes 19.5. From 15.5 to 19.5 is indeed the 4. And that's how you're kind of looking at it when that happens. 20 to 23, 24 to 27. That helps us do some of the other stuff, how you're creating, how you know what the class widths actually are. A little wider than you think they are sometimes, because you're making the 28, for example, 27.5, the 31, 31.5. Well, from 27.5, from 27.5 to 31.5 is 4. That's a space of 4, and that's what they're looking at. 32 to 35. 32 to 35, and here we go. Relative frequency. Well, 16 to 19. There's a 17, an 18, and 19. There's three of them. I see three of them. From 20 to 23, I see a 23 and a 20, and that's it. 23 and 20, there's two of them. 24 to 27, 24 to 27, I see a 24, and that's all I see. 28 to 31, I see a 28, I see a 31, so there's two right there. And 32 to 35, I see 1, 2, 3, 4. I see 4. I hope these add up to 13, guys. They're supposed to. And they don't look like they're going to do so. I think I missed something here. Well, let's look at it again then. And away we go. Let's see exactly where they're trying to go here. Let's see where that might have gone wrong, guys. There is a 17, an 18, and 19. There's three of them. That's it. The 20 to 23, there's 23 and 20. That's two. 24 to 27, I see a 24. Yeah, I see one right there. A 28 to 31, 1, 2. I see two right there. And 32 to 35, let's see here. I see a 32, a 33, a 33. That's 3. That's 4. You got me. Either I'm not counting right here. 7, I got 12. So I am missing one of them there, guys, for some reason here. Let me think. 20 to 23. 1. Yeah, it's looking good. 24 to 27. There's a 24. Yeah, I'm seeing that too. And 28 to 31. And there's a 29. There should 28 to 31. There should be 3 because there was a 29 present. Sorry about that. Well, I mean, better find out later than not. I mean, 28 to 31, yeah. There is a 28 present, there's a 31 present, and there's a 29 present. 28, 29, 28, 29, 31. That works. These add up to 7. That makes it, yeah. These add up to 7. That makes it 8. That makes it 10. That makes it 13. That sounds good. Let's just verify that. Stuff can get kind of tricky if you've been looking at it here. And you got this particular number, so what you got here are these are the actual numbers, and then for the frequency, you're going to go out of 13. 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 And just like these were adding up to 13, just like all the numerators added up to 13, with these ratios, the ratios will add up to 1. So let's just make sure. So relative frequency, this is the frequency of occurrence before you, the straight out frequency of occurrence, and the relative frequency you're dividing by 13. number of items present. 3 divided by 13 is 0.23. They're going 2 decimal places. Okay, let's make sure they were doing that here. They're saying here, yeah, right. Write each relative frequency as a decimal rounded to the nearest hundredth, not as a percent. Okay, so this one, and we'll circle these to know that. This is 0.23. 0.15. Now again, I don't know that they should add up to 1, but we're doing some pretty big round-offs here, guys. So it should when you add them all together, it should be close to 1. In this case, the way they asked us to do it is what we're doing, so we should be all right. 0.0769, that's 0.08. 3 out of 13, we already did that. At least numerically, we've done something like that. We got this. And 4 out of 13. .30769, that's 0.31. Should go in the ballpark of adding up to 1. Just like the numerators added up to 13, these ratios, these fractions, should add up to 1. Let's see exactly. Okay, let's just make sure. 0.23, 0.15, 0.08, 0.23, 0.31. Be about right. Just out of curiosity, 0.31 and 0.23, 0.54 plus 0.08, 0.62 plus 0.15, 0.77. 0.77 plus 0.23 is 1. Yeah, so it comes out there. Not guaranteed that it would, given some of the round-offs, but should definitely be close. Should get us in the ballpark. So let's see. These are the relative frequencies. .23, 0.15, 0.08, 0.23, 0.31. Okay, so that's for 2. Question 3 of 30. Question 3. The following list, for question 3, the following list contains the number of movies that a group of 10 students saw in theaters in the past 12 months. So it's 12 students. And here's the number of movies that they saw in the past 12 months. Find the median number of movies that the students saw. There's a lot you can be asked, obviously. Well, here they're asking the median. Usually it's good to put them in some kind of an order if you're going to do something like that. So let's see what we have here. Let's put them in order. 6 is the least. 10 is the second least. So let's see what we got here. We've got 6, 2 10s. That's the number of movies students have seen. Each student. One student saw 6 movies in the last 12 months. Another student saw 10 movies in the last 12 months. Another student also saw 10 movies in the last 12 months. So on and so forth. 6, 10, 10. There are 4 13s. And there's a 14, there's a 15. There should be 10 items here, guys. 1, 2, 3, 4, 5, 6, 7, 8, 9, and of course I did it again. And there's a 20. I'm sorry. Okay. Well, this should be all right. All right. 1, 2, 3, 4, 5, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Sounds good to me. What is the median? Go 5 over. Go 5 over. Average these two. Well, that's a pretty easy thing to average when they're both the same. And there's your median. Just check them, guys. I mean, like I said, if this stuff goes on film, I want it to be correct on film, at least when we're doing it. Yeah, we're getting 13 on that. Definitely getting 13 on that. So we're doing all right. Let's keep going. Well, I mean, let's, they did something a little, I want to make sure everything's on the, we're getting the same answer for this other problem that's about to happen here, and it's not, it's all right. It's not having nothing to do with that. That is definitely correct. We're going to get the same answer, 38.1, for this other problem that we're about to see. Let's see why. Even though the numbers aren't exactly the same. In the end, the averages, or whatever mathematics we're doing, is going to work out okay. For question number 4. It seems these days that students have to work more and more each week to be able to afford the cost of college. For a recent labor survey conducted by the government, there were 77 respondents who are working while attending college. The frequency distribution below summarizes the number of hours worked per week as reported by the respondents. Based on the frequency distribution, it's not relative frequency. The frequency distribution would have been the numerators here. But once you divide by the total number, it's relative frequency. So this is straight out frequency distribution. Based on the frequency distribution, using the midpoint of each data set, estimate the mean number of hours worked per week by the respondents. For your intermediate computations, use 4 or more decimal places and round your answer to 1 decimal place at the end. Hours per week is what you're going to get. So this is pretty neat. You know, it's weird. Yeah, they had 77 students that they were talking. They're talking about 77 students over there. We were talking about 78 students over here. But let's see what this means. So, I mean, let's exactly see what we want to talk about regarding this. From 26 to 30, number of hours worked per week, hours per week, 26 to 30. The average between 26 and 30 is 28. And there's 8 people doing that. 8 people doing 28 hours. There are 25 people going between 31 and 35. Well, between 31 and 35, if you want to get an average there, is 33. There are 18 people going between 36 and 40, inclusive. So the average between 30, these are all inclusive. If you want to be strict, 36 to 40 is 35.5 to 40.5, but that's another issue. 36 to 40 is 38. Okay, so we got that. 14 people are going to go 41 to 45. Well, the average between 41 and 45 is 43. There are 8 people going between 46 and 50, inclusive. The average between 46 and 50 is 48. And from 51 to 55, the average between those hours, 51 hours to 55 hours, inclusive, go high and low, 51, and then the low is 51, the high is 55. Add them together, average, we're talking about 53. And there's 4 people along those lines of an average. If you add that together, you're going to get something. And then, when you do get it, you're going to average, you're going to divide by 77, and you're going to hold it to the nearest tenth. Well, this should be interesting. Kind of a fortuitous answer, looking like just like number one. 8 times 28 plus 25. Okay. 8 times 28 plus 25 times 33 plus 18 times 38 plus 14 times 43 plus 8 times 48 plus 4 times 53. Again, assuming I plugged everything right here, I got 2,931. That's this. That's that. Okay. Well, then we're going to take this, divide it by 77, and get 38.0649. 38.0649. 38.0649 is going to round up to 38.1. And there it is. It's the first four for us, guys. Yeah, I mean, the way it was, not to beat this thing up to death or anything here, but, it's coming out, like we said, 38.06. Well, that 38.0649. Well, that 0 is a 0. Is it going to stay a 0 or go up to a 1? Well, bam, there you go. You got what you got. Okay, those are the first four. Question 5 of 20. A veterinarian treated 7 dogs this morning. The list below gives the weights in pounds of each dog. Find the range of the data set. Okay, that shouldn't be too bad. Might have enough room to do it here, actually, guys, before I start erasing everything wholesale, I guess. Let me go right here. Put number 5 right there. What is the range? Well, there's a number of ways you can look at it. They got the weight in pounds, 7 dogs. There's, find the range of the data set, 41, 36, 20, 36, 62, 5, and 6. I'll tell you what, let's just take the high, let's take the low, and we can take it from there. The highest in the list is 62. The lowest, quite a small dog, is 6. Do the subtraction, you got 56 pounds. Okay, let's check this. Make sure I'm not missing something. We should be okay, guys, for number 5. Yeah, we should be okay, and then should we be okay? We're not, actually. This is the reason why. Okay, we were talking about it over there. Hold off of that, please. Do not go there. They gave the whole list, like I said, went. And you see this written in different ways in different places. The whole list is 41, 36, 20, 36, 62, 5, 6. Aha. Well, 62 is the biggest. 6 is not the smallest. I just simply missed what was there. That's on me. 62, here's 5. And the range, 5 was the smallest. I missed that. I thought 6 was the smallest. 62 minus 5 is 57. see if they wrote pounds. They might have just wrote down the number. Very 57. I guess the range is a range of 57 pounds. They were using pounds, so I think you could put pounds there, but they're using 57. I'm sure you could put pounds there, though. Okay. That is the first 5 of the 20. Let's see. That's 5. Okay. Let's go to 6. For question 6, the following are distances in miles traveled to the workplace by 23 employees of a certain hospital. So let's take a look at that. There they are. That's a lot of data there, guys. There's 7, 2, 37, 32, 27, 22, 16, 11, 6, 1, 36, 31, 25, 20, 15, 29, 29, 24, 24, 9, 9, 14, 14. Quite a bit. Draw the frequency polygon for these data using an initial class boundary of 0.5. So you're going to start it at 0.5 so you can include the 1 that's in there, and an ending class boundary of 45.5 and 5 classes of equal width. Okay, we got to talk about that a little bit. Note that you can add or remove classes from the figure. Label each class with its midpoint. Okay, that's of interest. We're going to look at that carefully, and we'll see what we can say about it. Let me get this erased and kind of set up for us. Okay, everyone, we're back. I wanted to at least write this stuff on the board, not leave too much time where we weren't really talking, so I put it on pause a little bit and wrote this up here for you. The answer to problem 6 is this. Here's 6 people associated with this kind of median distance or mean distance or average distance within a particular group. 6 people, 5 people, 6 people, 5 people, 1. 6 people, 5 people, 6 people, 5 people, 1 person. They all add up to 23 people into consideration. Their commute times. What they wanted us to do was start at 0.5 and go all the way to 45.5 in terms of miles. A commute of half a mile all the way through a commute of 45.5 miles. When you subtract these two values, you get 45. When you divide it by 9, you get a width of 5. So basically, try to look at this. I guess, forgive me, that's actually not what we want. The mathematics is significant, but we could say that if you go, let me write this and then let me erase it. The width for each group is 9. If the total range is 45 and they're equally spaced groups, it's 9 miles width, 9 miles width per group. So this is the width. 9 miles width per group. There's a total of 45 miles. When you go 45.5 minus 0.5, you get 45. 45 divided by 9 miles per group, that's going to give you 45 divided by 9, it's going to be 5 groups. And that's where this is coming from. Well, this one right here runs from 0.5 to 9.5. Well, what's 0.5 plus 9.5? It's 10. 10 divided by 2 is 5, so I'll go right in the middle. This one goes from, so basically they're going from 0.5 to 9.5. Let me add these two together and divide by 2, I get this. Then the next one goes 9.5 to 18.5. Let me add them together to, let me add them together and divide by 2. So what happens here is, like I said, we added these two together, got 10, divided by 2, we got 5. Add these two together, we got 28, divided by 2, we got 14. Add these two together, we got 46. Yes, 46 divided by 2, we got 23, so on and so forth. 64, when you add these two together, divide by 2, you get this. 82 here, divide by 2, you get this. Okay, those are the middle of each group. The width of the group, 9.5 minus 0.5 is 9. 18.5 minus 9.5 is 9. 27.5 minus 18.5 is 9. 27.5 minus 18.5 is 9. 36.5 minus 27.5, 9. And 45.5 minus 36.5 is 9. So the width of each of the 5 groups is 9. There's 5 of them, each one with a width of 9. 5 times 9 is 45, the whole range we're talking about. The middle of this is 5, middle of this is 14, middle of this is 23, middle of this is 32, middle of this is 41, and that's what we have. You know, the middle of the first one is 5, middle of the second one is this, middle of the third one is that, middle of the fourth one, middle of the fifth one. And how often are they occurring? Well, within that range of 0.5 to 9.5, you got 5, forgive me, within that range, within that particular expanse of 0.5 to 9.5, we got 6. From 9.5 to 18.5, we got 5. From here to here, we got 6. From here to here, we got 5. From here to here, we got 1. So that's pretty interesting how that all plays out, you guys. And this is pertaining to frequency. Pertains to frequency here, here, so on and so forth. So that's kind of where they're going. So it's some interesting stuff to look at. It lends itself easier when you put it all up on the board. Now, like I said, those 23 employees, man, those 23 numbers look like a lot of numbers. Relatively speaking, that's a lot of numbers there. But you can put them in order. You just got to figure out how frequently is something occurring between 0.5 and 9.5. How frequently is something occurring between 9.5 and 18.5, those first two? How about how frequently is it occurring between 18.5 and 27.5, et cetera, down to the end of that thing. And that's kind of where they're getting this. So that's number 6, you guys. Question 7. Question 7. To inspect manufacturing processes, companies typically examine samples of parts for deficiencies. One company that manufactures ballpoint pens selected samples of its manufactured pens on each of 9 days. The company recorded for each sample the number of defective pens in the sample. The company recorded for each sample the number of defective pens in each sample. Here are their data. Over the 9 days, 29 were bad. One day it was 29 were bad, another 29 were bad, and another day, then 17 were bad, then 21, 21, 29, 22, 21, 25. ABC, what are they talking about? What is the mean of this data set? Now, again, there's a lot going on here, guys. They didn't really tell us a lot of what they're doing. They're just saying they selected from samples. They made samples. Well, they didn't really specify beyond that. There's more to it, potentially, if you're going to go that way, but we're not going to worry about it. They're not worried about it. We're not going to worry about it. Let's talk about 7. A, what is the mean of this data set? Is your answer not an integer? Round your answer to 1 decimal place. B, what is the median of this data set? If your answer is not an integer, round your answer to 1 decimal place. That seems where we're going here. How many modes does the data set have, and what are their values? Indicate the number of modes by selecting the appropriate line, and then indicate the values of the modes if applicable. Okay, ABC. So you're talking about mean, median, and modes, and we can take it from there. Okay, sounds good. Okay, let's see what we got. They write them down. I'm going to do them in some kind of an order here, guys, and see what I can do. I'll go from small to big. There's a 2. There's a 17. There's a 2. There's a 17. There's 3 21s. There's a 25. And there are 3 29s. Well, there are 2 modes. There's 3 29s or are there? Yeah. There's 3 21s. There's 3 21s and 3 29s. We'll cross that bridge when we need to do it. First things first, what is the mean in this data set? You're going to add all 9 of this data and divide by 9. Simple as that. So for the mean, see what we got here, guys. Maybe there's a shortcut here in the making, I guess. 21 and 29 is 50. 21 and 29 is 50. 21 and 29 is 50. There are 3 50s, that's 150. 150 plus 25 is 175. Plus 19, 175 plus 19 is 194. The mean, let's have a look at it. $21.55555 on forever. That's 21.6. So we got that. That's the mean. Let's make sure I didn't make any careless errors. I'm prone to them sometimes. We got to just always check what we're doing. That is 21.6. Yeah, indeed, it is 21.6. What is the median of this data set? There's 9 of them. You go to the geometric center of the thing and it should be okay. There's 1, 2, 3, 4. Here's 5. There's 1, 2, 3, 4. There's 5. Yeah, the median's right in the geometric center. There's an odd number of terms there. Go right to the center and it's 21. Simple as that. C. How many modes does the data set have? Has 2 modes. What are their values? Indicate the number of modes by selecting the appropriate line and then indicate the value of the modes if applicable. There are 2 modes. They are 21 occurs 3 times and 29 occurs 3 times. And there you go. That's 7. 8. The citizens of a certain community were asked to choose their favorite pet. The pie chart below shows the distribution of the citizens' answers. If there are 100,000 citizens in the community, how many chose hamsters or cats? Let's say every one of them voted, you guys, and said something. Well, there's a pie chart there, and they're basically telling us this. 13% like fish, 6% like snakes, 11% like hamsters, 25% like cats, 21% like birds, and 24% like dogs. How many chose hamsters or cats? Well, that means you got an option. If you've got an option, there's more selection, I guess. There's going to be bigger numbers here. Well, basically, how many chose hamsters or cats? Hamsters, 11% of the survey did that. We're assuming all 100,000 people. Voted. I mean, let's say 11% of those 100,000 people, or some sample of it, chose hamsters, and cats was 25%. %36 chose one or the other. I think that's all they're doing here. They're not asking, if you want to throw a number out of there, if 100,000 people voted, 36% out of 100,000 people is 0.36 times 100,000. That's 36,000. I don't think they went there. They just went for the percent. I said I don't think they went there, and you know what? They went there. Let me see here. The pie chart shows the distribution of the citizens' answer. How many chose? How many? Okay. Well, this percent of people chose it, and I was right. If they're going to ask that, and they are asking that, I didn't read it right. 36% of this, which is equal to 0.36 of this, which is 36,000. 36,000 chose in this particular manner. Absolutely. So, 36% is what it is, and it comes out to 36,000 when we're doing that. I mean, it's a question like that. It's a little bit wide open how it can be said sometimes. Number 9, you've got a lot of data points there. Draw the histogram for these data using an initial class boundary of 20.5 and a class width of 5. Note that you can add or remove classes from the figure. Add each class with its endpoints. Okay. There are a whole lot of numbers there. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I think I got 20 here. Let's see here. 3, that's 5, 8, 10, 13, 15, 18, 20. There's 20 items there, guys. They want you to start at 20.5 and a class width of 5. So what you're doing here with that one, I may need to erase a good portion of this stuff, maybe not. Let's see. We already did this pretty hard the last time when we did it. You are essentially doing the same thing again. This is the frequency. And it goes, I didn't give myself any room. Now, let's try that again. Here's 0. They kind of chop it a bit here. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, I guess. Let's see, we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I took it a little further than they took it, I guess. Time in minutes. They want five groups. 1, 2, 3, 4. So they drew something here. Okay, the initial class boundary is 20.5 and a class width of 5. So if you got this, And you can set this up as you wish, but you're going basically, draw the histogram for these data points, draw the histogram for these data using an initial boundary of 20.5. 20.5 with a class width of 5, so you add 5 to this, you go 25.5. You go 25.5, add 5, you got 30.5, you got 30.5, and you go 35.5, you go 35.5, and you end up at 40.5. So let's see what we got here. Keep going. 40.5 to 45.5, 45.5 to 50.5. I think that's as high as it goes. The highest it went, I don't even need to go that high, actually. I'm kind of going, 43 is about as high as it goes. You're probably looking about, you could probably stop it right here, because 43 is as high as it goes. You can go to here. But like I said, conceivably, if you're going to keep drawing these, you're following the idea, the rule, I guess, that they're going to be 5 wide. You're starting at 20.5, and you got what you got. See how it went. I mean, they kind of cut us to the chase pretty well on this when we talk about it. They wanted a histogram in this case, right? So saying, draw the histogram. Well, you start where you start, and let's see where we go. We go 20.5, so here we go again. 20.5, 25.5, 30.5, 35.5, 40.5, and 45.5. Okay? We see it in the answer key as well. Now you draw the histograms and see where it's going to go. From 20.5 to 25.5, it goes up to 7. So it's going up to here to here. This is not a good drawing on my part, but here it is. And that's 7. That's 7 tall. There are 7 people out of the 20. 7 people out of the 20 that are within this set of data from 20.5 to 25.5. And there's 7. From 25.5 to 30.5, it goes up to 5. From 30.5 to 35.5, goes just to 2. Thirty 30.5 to 35.5, so you got that. 35.5 to 40.5, also 2. 40.5 to 45.5 goes up to 4. They better add up to 20, guys. 7 and 5 is 12, and 2 is 14, and 2 is 16, and 4 is 20. Sounds good to me. And again, you count the counting process is pretty tedious. We got away from that. We just knew there were 20 items there. Likely, I think the best way to do it is put them in some kind of order from smallest to biggest, and then group them according to where they would fall here. Okay? So it's looking pretty good. Okay, guys, we got that. That was number 9. Let's go to number 10. Number 10, the hourly wages of a sample of 44 employees of a clothing company are summarized in the table. There are 6 employees that make $6.5 per hour. There are 17 who make $8.25 per hour. There are 5 who make $9.75 per hour, and there are 16 who make $10.75 per hour. Find the mean hourly wage of these 44 employees. Round your answer to at least 2 decimal places, and you're there. All right, so that would be number 10, guys. So let's have a look. Okay, everyone, let's keep going. So we're looking at the following. Let's look at problem number 10. All right, guys. I mean, there's not the way they wrote it. We can write it and go for it as well. So let's see. They've got, here's kind of the long story short. Of the 44 employees, 6 of them are getting $6.50 per hour. 17 are getting $8.25 per hour. 5 are getting $9.75 per hour. And 16 are making $10.75 per hour. Well, that's where it is, guys. So let's figure out, and there's 44 people. So to find the mean hourly wage, we'll take that sum and divide it by 44 people who are employed. So let's see what we have here. A number of ways to go here. The easiest let's just go to the calculator and do it. Plus 16 times 10.75. Okay, guys, I hope I did this right. I guess we'll find out. I got a total of 400 divided by 44. So let's see where that goes. $9.0909. So 9.0909, 9.09. For some reason I'm not really comfortable with what I did with the calculator, but I'm assuming it's right. Let's just take a look. So always double check your work when you're doing this stuff, guys. 10, there it is. Yeah, indeed. It's correct. $9.09, $9.09 per hour. That was number 10. Let's go to 11. Let's go to 11. Question 11 of 20. Question 11. The monthly salaries in thousands of dollars. For question 11, they're talking about the monthly salaries. The monthly salaries in thousands of dollars of a sample of 6 sales representatives are as follows. 12, 9, 11, 8, 6. 12, 9, 11, 8, 6, 8. Find the standard deviation of this sample of monthly salaries. Round your answer to 2 decimal places. So there's 6 sales representatives. There's a number of tricks to do this. Right now, I don't know if I'm going to show you all the tricks on how to do some of this stuff. When we're in person, we can maybe talk about it in greater detail. If necessary. There's some interesting subtleties to the whole process, I guess you could say. I guess one way to do it is, let's stay with the thousands of dollars. Maybe that is okay. You don't have to go to the thousands to actually knock it out that way. There is 12, 9, 11. Let's see what we got here. There's 12, 9, 11, 8, 6, 8. So let's go. We'll put the thousands at the end. So that works okay. Believe it or not, there's a lot that goes on, but in the end it works out. Yeah, you don't have to put the thousands in there. Let's leave it at that. I mean, so maybe that's good for us. Let's add them up. 12 and 9 is 21, and 11 is 32, and 8 is 40, and 6 is 46, and 8 is 54. There's 54 divided by 6. So you've got a total of 54 divided by 6. That's 9. Not bad. That means $9,000 per month. Okay? Let's go with that. That's the mean. That right there is the mean. X bar like that, it means mean. So what you're going to do is you're going to take each of the items and get a difference and square it, sum them up, and divide by the quantity minus 1, and then square root it. This is easier done than said, guys. I'm going to take 12 and subtract 9 from it and square it. I'm going to take 9 and subtract 9 from it and square it. I'm going to take 11 and subtract 9 from it and square it. I'm going to take 8 and subtract 9 from it and square it. I'm going to take 6 and subtract 9 from it and square it. And I'm going to take 8 again and subtract 9 from it and square it. I'm going to sum all of these. Sum all of these together and divide by n minus 1. The n is 6. There's 6 items. You're going to divide it by the number of items minus 1. When you're done with that, you're going to take the whole thing and get the square root of it. And that's going to give you the standard deviation at the end of all that. Well, yeah, it's a bit, but we can do it. Let's figure this out. We just do it. We can do it in our heads too, I think. 12 minus 9 is 3 squared. That's 9. 9 minus 9 is 0 squared. That's 0. So we just got 9 right here. This is 2 squared. That's 4. 4 and 9 is 13. This is negative 1 squared is 1. 1 and 13 is 14. This minus this is negative 3 squared is positive 9. Positive 9 and 14 is 23. This is 1, and that should be 24 divided by 5. Now, I'm sure I probably made a mistake doing this. Let me just kind of do it in my head and then see where it's coming at us again, guys. See where it goes. Looking at this, I got 9, 4, that's 13. That is 14. That is 23. That is 24. 24 divided by 5. And then you're going to square root it. And sounds good to me. (24) divided by 5. Right. 2.1908. Yeah, okay. 2.1908. I think they wanted 2 decimal places when they did this, right? Round your answer to 2 decimal places. So 2.19 is the standard deviation. This is interesting. It's 2.19 in thousands of dollars. Every one of these had thousands of dollars associated with it. Had $1,000. I think it was, let me see how they put it here, in thousands of dollars. It's 1,000. Every one of these had 1,000 in it. If you square 1,000, it's a million. I get all that. You can pull the million out of all that, then square root the million, it's back to 1,000. So this in thousands. I don't know how they're going to play it. Let me look at how they gave the answer. This is the right answer. Should be fine. 11, 2.19. True, and they'll let that go. They're going to let that go. That's 2.19, true. But it's in thousands. It really is in thousands. Thousands were present here, and at the end of the day, it's going to be present. So that's pretty fascinating stuff in its own right, how that all works out. So you got that. And that was 11. Question 12 of 20. 12. Here are the test scores. Question 12. Here are the test scores for 10 students in Mr. M's class. 76, 97, 72, 95, 84, 96, 95, 54, 81, 87. What is the percentage? What is the percentage of these test scores that are less than 73? Well, that's pretty interesting. There's a lot of number of ways we can go with that. So let's just go with it the way we know it. Let's put it in some kind of ordering here, guys. It seems like the lowest score is 54, then it's 72. So 54. Let's see what we got here. We got 54, 72, 76, 76, 81, 84. Okay, hopefully I didn't go too fast on that to throw myself off on it, but we got 84. After that, you got 81, 84. You've got 87, 87, 95, 96, 97. 87, 95 twice. 95 twice, 96, 97. Longest list of 10 I've seen, is it? Let's see what it is. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What the heck? Let's see, 10 students. Okay, that's interesting. I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's a 54, a 72, and that's it. The 72 should not have occurred twice. It was... Yeah. Sounds about right. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, sounds a little bit better. What percentage of the test scores... What is the percentage of these test scores that are less than 73? Right here. There's 2 of them out of 10. 2 out of 10, 20%. Okay, guys, I think that's right. I mean, it should be okay. Hardest part of these things, these problems sometimes, is just counting. Make sure you get a good count on the thing and don't do anything careless. Like I've done more often than I would wish to have done. What are you talking about? 12 is 20%. You got it. You got it. 12 is 20%. So at that point, that's 12 Let's go to 13. They're playing now. They're kind of playing the same game with us here that they played with 12. They're being a little more rigorous about it, a little more complicated. But for problem number 13, okay, let's see what we have here. Right. Okay. Let me just check something, guys. I'm always checking the sound quality and stuff like that really quickly if I can. Sounds good. Everything looks pretty good, guys. For question number 13, the following are, for problem number 13, the following are distances in miles traveled to the workplace by 18 employees of a certain computer company. And there they are. There's 18 numbers there in front of us. Find the 25th and 60th percentiles for these distances. Again, that's kind of here. This is the 73 here. 73 was basically the 20th percentile because 20% of things were less. 20% of things were less than 73 of the things that were here. So that's kind of the game they're playing as well, right there regarding that stuff. So as we see this, let me try. Okay, so for 13, there's a number of things there. I mean, obviously, it looks like we're in a situation we're just going to go for it as well. We're going to write them out and write them out okay, I guess. So here's 13. Let's go. There is a 1, a 3, a 5, a 6, a 7, and a 10. A 1, a 3, a 5, a 6, a 7, and a 10, I think. Let me see. There's a 1, a 3, a 5, a 6. Yeah, right. Let me just make sure, guys. There's a 1. I can't find the 3. Okay, there is. There's a 1, a 3, a 5, a 6, a 7, a 10. Okay. There's a 13, a 14, a 13, a 14, a 16, and an 18. A 13, a 14, a 13, a 14. Let's have a look here, guys. A 13, a 14, a 16, and an 18. And an 18. See what else there is. I mean, there's a 25, a 27, a 29, a 25, a 27, a 29. There's a 31. There's a 31, a 34, and 36. How many are there, guys? Let's see what we got here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Got a 36 over there, don't I? Yeah. Let's have a look. For some reason, There are multiple occurrences of something, perhaps. Let's see here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. There was a 9 in there that I didn't put in there. There's a 9 in there I didn't put in there. Okay. I don't think there's multiple occurrences of some things, just some things not showing up. The biggest is 36. Second biggest is 36. Is there 13 there? There's a 1, a 3, a 1, a 3, a 5, a 6, a 7, a 9. A 1, a 3, a 5, a 6, a 7, a 9, a 10, yeah, there's a 10 there. For the life of me, there's a 13. There is a 28 that I did not put in there. And I think we're set. Again, the hardest part is counting this stuff. Counting it out, at least it is for me. I don't know, some other people might have an easier time. 28, 29, and there you go. Find the 25th percentile and 60th percentiles for these distances. Everything we got, what did we say? We got 18 here, right? 18, break it up into quarters. Each one is 4.5 big. So you'd go 1, 2, 3, 4.5 right here. I'm looking at the 7 being the 20, the thing calling the shots there. It's not hitting right on something. It's a half. 60th percentile. So you went, as I said, we went 0.25 times 18. We got 4.5. So everything less than, the last 4.5. So this guy right up here rules the show, and these go down. 60% of 18 is 0.6 times 18, which is 10.8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that'd be down there. That'd be the 60% down there. I got 7 and 18 doing that. Unless I somehow read this wrong or went about it wrong. Let's see here, but it should be okay. Okay, what they're doing, okay, I see what they're doing. Okay, something different than what I did. Okay, guys. I've seen this written different ways, I guess you could say. You could say a bunch of stuff. I mean, you could say 25% of 18, which is 0.25 times 18. We could look at it, try to think here, guys. I think they're getting the averages and taking it from there. Let me hold off on this for 1 second here. I wanted to make sure I'm looking at this correctly. I'll be back with you in 1 second. Okay, everyone. I had to step away for a second here. I wanted to kind of look at this. There's a couple different ways this can be looked at, conceivably, at least according to my judgment, according to my knowledge. But this warrants some consideration here. So let's look at it. Kind of make a long story short. There's not necessarily a whole lot wrong with looking at the data the way I initially looked at it, to say, okay, there's 4.5. If there's 18 pieces of data, the 25th percentile would be 25% of 18 is 4.5, and we go right about here. 60% of 18 is right about here. Well, yes and no. I've seen, unless I have seen it wrong, I've seen analysis in a real kind of generic, very simple way of looking at stuff where this is kind of allowed in some circumstances. They're looking for a more sophisticated answer here. Looking at the book, it wasn't, I perhaps haven't seen it that well. I'm probably missing something. It wasn't too helpful. I had to look somewhere else to kind of get refreshed on the whole process. But basically what they're trying to say is they want a 25th percentile and they want a 60th percentile. And the way you go is, we've got 18 items here. What you do is kind of make it an easier way to look at. Like I said, what I'm looking at here conceivably could give you some kind of a gut feeling as to what's going on. But let's not go there. I mean, it gives us a little bit of a gut feeling of what's going on with the 25th percentile and the 60th percentile. But I'll tell you what, maybe there's, like I said, they're telling us a little bit different way to kind of look at what's going on here, you guys. I said what I said, but let's say something different. And let's get the answers that they're getting for us. Tell you what you're going to do. You've got the way this is going to play out is you say, okay, there's 18 items total here. It goes from one item all the way to the 18th item. So 1 plus 18, get an answer, and then multiply it by 25%, which is 0.25. So you're getting 0.25 times 19. And when you do this, I'm going to have to get our calculator, guys, on this one. I was looking at it a bit, and it's a rather interesting scenario here, I guess you could say. 0.25 times the sum of 1 and 18. So 0.25 times 19. Okay. 4.75. So what we're doing is you got to go to the 4.75 location. I kind of sort of did that here. It's 1, 2, 3, 4. Here's 4, here's 5. 4.75 is between the two, more towards 7. What you do is you take, since it's between 6 and 7, you take 6 and multiply it by the tail end of this. And we'll see what we get. You get 0.75 times 6 no, forgive me, not that actually. The difference between the two, actually. Yeah, I told you, there's a reason the book didn't cover this, or at least I didn't see it get covered there. You'll take the two. You said it's at a location 4.75 out of 18. Start at 1, you go to 18. I add 1 and 18, I get 19. 19 times 0.25 is 4.75. 4.75 is 1, 2, 3, 4. This is 5. This is 4. This is 5. 4.75 is right here. Well, 75% of the way between the two is 0.7, is 6. Here's 6, here's 7. It's 6.75 to make a long story short. The way you do it is you take 7 and 6, you get the difference between the two, and you multiply by the tail end of the 4.75, and you get 0.75. You add that onto the 6, and you get 6.75 regarding 25th percentile. '25th percentile, you're getting this. You're going to play the same game with the 60th percentile. You're going to call the 60th percentile 0.60. You're going to take first, how big is this thing? Well, it's 18 big. I'll take the first and the last and then multiply it by 0.60. 0.60 times 19. And when you do that, you get 11.4. Okay, you take the 11.4, what location 11.4, huh? This one was, I mean, the other one was at location 4.75. 1, 2, 3, 4. 1, 2, 1, 2, 3, 4. 1, 2, 3, 4, 5 between the two. And we did all the monkey business. We got that answer. That's for that one, for the 25th percentile. If it's 11.4, you're going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11.4 is between these two. So get the difference between the two, which is 25 minus 18, and multiply by the tail end of the 11.4, the 0.4, and you're going to add that on to the 18. You've got 0.4 times 7, that's 2.8. 18 plus 2.8 is 20.8. And that's for 60th percentile. So you got two items here. And those are both the answers that they gave. Now, I haven't looked at the book in the greatest detail, but I tried to look at it relatively well whenever needed, and I couldn't find this approach anywhere. Perhaps it's there. I'm sure it's there somewhere. I'm probably just missing it, but I couldn't find it anywhere. I had to look elsewhere. So there's kind of like a very easy, generic way of looking at something. It gives you a ballpark idea of what's going on, and there's a more specific way to do something. And that more specific way, you're getting the 6.75. You're getting the 6.75 for the 25th percentile and the 20.8 for the 60th percentile. So let's finally verify that. Sorry about that, guys. That's why I had to take a little bit of a break from there. Make sure we were on the mark at some point at least. Yeah, the 25th percentile, the 25th percentile is 6.75 miles, and the 60th percentile is 20.8 miles the way we've done it. Just got to put miles on it, but that's the thing. So remember that. It's an interesting technique. We can look it up on the internet. That's what I ended up doing. I could not find it in the book. But we do have it here, guys. So that's 13. That's 13 regarding this matter. take a little break, and we'll come back at it. We'll come, we'll talk again. We'll talk soon regarding questions 14 all the way through the end. We'll talk very soon. Okay, let's continue. Finishing up practice test number 7. Let's go to question 14. The salaries of the employees at 4 companies are summarized below. Answer the questions about them. Company A, Company B, Company C, Company D. They want to ask, Company A, the mean salary is $36,000 and the range of salaries is $54,000. Company B, the mean salary is $39,000 and the range of salaries is $53,000. Company C, the mean salary is $45,000 and the range of salaries is $49,000, and the mean salary for Company D is $42,000 and the range is $55,000. Based on the information above, which company's salaries have the most variability? A, that's A. B, based on the information above, which company has the lowest salaries on average? So it's pretty relatively easy stuff. I'm going to let you guys, again, this scrolls at the end of the video, this test number 7, so you can look at it and kind of match it up, save us a little bit of time here. Here's A, here's B. Based on the information above, which company's salaries have the most variability? Probably the one with the greatest range is where we'd want to go with that. I think they'd go with D. Let's just see how they're doing it. Again, there's different criteria so oftentimes when things get said, guys. Let's have a look at it really quickly. Yeah, right. Company D, because it does have the greatest range. The greatest range is $55,000. It's more than any other range in the 4 companies present. Which, based on this, which company has the lowest salaries on average? Well, that's pretty obvious. That's going to be A. So they talk about that, and they get you to there. Go to 15, guys. 15 is saying, question number 15, problem number 15. Last year, over 13,000 students took an entrance exam at a certain state university. Justin's score was at the 19th percentile. Yoko's score was at the 36th percentile. Which of the following must be true about Justin's score? And that's for A. And then B, which of the following must be true about Justin's and Yoko's scores? Justin got 19% of the questions correct. No. Justin's score was in the top half of all scores. No, it was quite low. Justin missed 81 questions. That's not necessarily true. Justin scored lower than about 81% of the students who took the exam. That's the one. That's the one. I don't know if they put any kind of letters here. So Justin scored lower than about 81% of the students who took the exam. That's A. That's for part A, the answer. Justin scored lower than 81% of the students who took the exam. B, which of the following must be true about Justin's and Yoko scored? Yoko scored 17 more questions correctly than Justin. No. Justin scored 17 more questions correctly than Yoko. No. Both Justin and Yoko scored above the median. No. Both Justin and Yoko scored below the median. Both those. Last option for this, and also last option for this one as well that they were giving. I don't think they put letters on it, so I'm kind of answering it like that. Right, last option for both of those, and we already kind of explained that. Let's go to 16. 16 of 20. The ages of the members of for problem number 16, the ages of the members of 4 teams are summarized below. Answer the questions about them. Team A, The range of ages is 11, and the mean age is 39. B, the range of ages is 4, and the mean age is 40. C, the range of ages is 8, and the mean age is 43. D, the range of ages is 5, and the mean age is 36. Based on the information above, which team's ages have the most variability? It's got to be Team A. It's got to be Team A. There's a range of 11. That's the biggest range present, you guys. So when we look at that, so what do we got here? We got that, and that's got to be Team A. Based on the information above, which team has the oldest members on average? Well, it's pretty obvious. The average is 43 for Team C, and that's the highest average of all. So you're looking at that. You're looking at Team A, Team C, respectively, for that. Let's just quickly look at that. Team A, yeah, right. Team A and Team C, absolutely, for those two. So very good, very good. See what we have here, guys. Number 17. Government agencies keep data about the income distribution of the population. Okay? Government agencies keep data about the income distribution of the population. The Choi family and the Stewart family live in a county with 5,000 families. The Choi family's income is at the 19th percentile. The Stewart family's income is at the 61st percentile. Which of the following must be true about the Choi family's and Stewart family's incomes? Both the Choi family and Stewart family earn more than the median income. That's not true. The Choi family is lower than the median income. Both the Choi family and the Stewart family earn less than the median income. That's not true. The Stewart family owns above the median income. Third option, the Stewart family earns more than the Choi family. Yeah, that looks that looks obvious. The Choi family, the other option, last option is Choi family earns more than the Stewart family. No, they're in the same county, 61st percentile. Stewart family earns more, so that is 17A. Stewart family earns more. That is the third option. B, which of the following must be true about the Choi family's income? About 19% of the families in their county earn less than the Choi family. That's about right. The Choi family earns about 19% of the highest income in the county. That's not how it works. The Choi's family income is in the top half of incomes in the county. No, they're in the lower end of that. The Choi family earns $19,000. No, we didn't have any kind of numbers to tell us that. About 19% of the family in their county earns less than the Choi family. First choice. That's the first choice. So we got that, you guys. So what do we got here? That was 17. So we got, for A, the third choice, the Stewart family earns more than the Choi family. And for B, we got the first choice. B, first choice. So third choice and first choice as we go. Third choice, right. Third choice for A, first choice for B. All right, looking good, guys. Let's talk about 18. So we're looking pretty good, guys. 18. Question number 18, problem number 18. Here are the shopping times in minutes for a sample of 6 shoppers at a particular store. Find the standard deviation of this sample of shopping times. Round your answer to 2 decimal places. There are 6 times right there, guys. Let's put it in some, I don't know that we need to actually put it in some kind of order, but we can. Why not? Force a habit in a sense. How about 30, 30, 33, 34, 30, 33, 34, 38, 38, 43. What we have is we're going to do an addition. This, and this, for starters, is going to be 97. With this, it's going to be 135. With this, it's going to be 173. We'll say 176 and 216, I think I'm getting here, guys, divided by 6. But I'm not trusting myself too much these days on this. Let's see what we got here. We got 30 plus 33 plus 34 38. Don't trust my final answer. Let's trust this answer that we're going to get. 216. Okay, trust it. Divided by 6, that's 36. That's the mean, the average. Let's go for it. We're going to take 30 minus 36, square it. We're going to take 33 minus 36, square it. We're going to take 34 minus 36, square it. We're going to take 38 minus 36, square it. 38 minus 36, square it. 43 minus 36, square it. There are a total of 6 items. You are going to take 6 minus 1, divide it into that sum. When you're done, you're going to get the square root of that whole thing. We've been there, guys. We've done that. Okay, so let's see where we want to go on this thing. Kind of do this in my head, and then we'll square it as we go along, I guess. 30 minus 36 is negative 6. You square it, you get 36. 33 minus 36 is negative 3. Square it, the entire quantity, you get 9. 34 minus 36 is negative 4. Square it, you get 4. 38 minus 36 is 2. Square it, you get another 4. Same thing here. Same exact answer. You got a 4 right here. And this minus this is going to be 7. 43 minus 36 is 7. You square it, you get 49. Divide it by the difference, 6 minus 1, divide it by 5. And get the square root of that. 4.6043. Round your answer to 2 decimal places. I'm getting 4.6043. 4.6043, that's 4.60. Well, I don't know if I need to get too elaborate, guys. I want to make sure I did this right. I may have done this right, and the answer key might be wrong as well, but usually the answer key is pretty spot on, more than I am. 4.6, 4.60. 4.60 is a little more accurate when they're saying to 2 decimal places, but 4.6 means the same thing. Let's go to 19. 19, here are the heights in inches of 12 students in a seminar. There they are. What is the percentage of these students who are shorter than 65 inches? Interesting. Okay, shouldn't be too bad. Let's take a look at it. Well, there are 12 students there, guys. What is the percentage of these students who are shorter than 65 inches? Let me just go down the list. You guys have the list. It's going to be scrolling for you. If you're in my class, you actually have the hard copies, or you can easily print them out. As far as, and this will scroll at the end of the video anyway, so let's just take a look here. There's 71, 67, 62, 60, etc. There's going to be a total of 12 of those. Let me see who is shorter than 65 inches in height. There's a 62, a 60. There's a 62, a 60, a 64. There's 3 right there. A 58, that's 4. A 63, that's 5. A 60, that is 6. 6 out of 12. I think it's about as easy as it looks. 6 out of 12, 50% are going to be shorter. Make sure, I mean, it should be pretty straightforward. Of the 12 of those, half of the people are shorter than 65 inches in height. There was a 62, a 60, a 64, that's 3. There was a 58, a 63, and a 60, that's another 3. And the rest is taller than that. So it should be pretty on the mark when you do that, 50%. Simple as that. Number 20. Number 20, the following are the annual salaries of 16 chief executive officers of major companies. The salaries are written in thousands of dollars. There is 16 of them. There's, and there they are. I mean, so let's look at it. Let's get it. Try to put these in some kind of an order here, guys. It's not always the easiest thing to do, but let's see what we can do. So we've got $248. We got $224 before that. Told you it's not easy sometimes, huh? 224, 248. We'll figure it out. I mean, if we got to just put stuff in on the side here, we'll figure it out. 224, 248, 271. $315. $362. $405. See here, 405, $495, $519, $542. 562 562 586 586 676 743 790 814. It's quite a bit. If I even got it all. There's a 519 here. Um, 814, 1250. Wow, that's a lot. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Was there a 519 already? There was. Okay. Yeah, we got it. It's fine. It's fine. Let's see again here. 2. Let's see what we got here. 2, 4, 6, 8, 10, 12, 14, 15, 16. Sounds good to me. Find the 10th and 75 percentiles for these salaries. The way you're going to do it is how we did it last time. It's a little something that was very hard to find in the book. Perhaps it is in the book and I'm simply missing it. That certainly could be the case. There's 16 items here. You're going to take, there's 16 items, item 1 all the way through 16. You're going to add 1 and 16. Then you're going to take 10% of that. 10% is 0.1. 0.1 times this sum is 1.7. And you are going to go from 1 to 2. You're going to be between it right here. You're going to be between it right here. And it's going to be something there. You're going to take the difference between these two, 248 and 224. It's a difference of 24, the difference between the two. You're going to multiply by 0.7, and you're going to add it onto this. So when you do this, you end up getting, let's see, 175, 168. I think it comes out to 168, 1.68. You're going to add 1.68 onto here. So again, this is the way this happened was you took the 0.7 and you multiplied it by this difference. The way this plays out, 140, 168, yeah, let me see. If there's no decimal here, this would be 168, 1.68. You add the 1.68 onto here, so for the 10th percentile, for the 10th percentile, you're going to have 1.68 plus, starting here, the 224 plus 1.68 is 225. 0.68. Did they say do any kind of round-offs? I don't think so. So, okay, let's see what we got. 225.68. Let us see. $240.8. That makes no sense, but that's the answer they're given there. Got to be more than that. Oh, forgive me. Yeah, no, there's nothing wrong. They did nothing wrong. I did wrong. Okay, let's try that again. The setup was right. My arithmetic was wrong. I guess I should be using a calculator more than I choose to use a calculator sometimes. Let's try that one more time. This is what you're doing. This multiplication right here is going to be one decimal place over. This would come out if there was no decimal place here. If there was no decimal place here, this would be 168. Because of the decimal place, it's 16.8. There you go. You're going to take the 224, add 16.8. My fault, guys. And that comes out to 240. Just bad arithmetic on my part. That doesn't make it any less wrong. I was wrong. This is how you do it. $240.8. It's basically, guys, essentially the same argument. It is essentially the same argument when you're going to go to the 75th percentile. You are going to look at it and say, okay, so that was the 240. $240.8. Now the 75th percentile, how are you going to do it? You're going to do the same thing. You are going to take, so this is for 10th percentile. Okay. All pertain to the 10th percentile on that one. Let's keep going. You are going to take 75% of the first numbered item, the beginning, until the last, right here, and you're going to take 0.75 of 17, and you're going to take it from there. So, and that is going to tell you, I'm not even going to try to do that one in my head. I probably might be able to do it, but why take your time on that? 0.75 times 17, 12.75. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12.75 place. Here's 12, here's 13, here's 12.75. Right here. So let's see here. You go all the way across. You count here. You got 10, 11, 12. Here's 12. Here's 13. Here's 12.75. You're going to add 0.75. You're going to actually add. You're going to get the difference between these two. 743 and 676. So 743 minus 676, and then you're going to multiply it by the tail end of this, 0.75, and that's what you're going to tack on to the early guy. So there's 10 up here. You go all the way 1 through 10, 11, 12, 13, 12.75 is right here. 12.75 is between the 12 and the 13. Get the difference between the two, multiply by the tail end 0.75, and you'll find where you are. So you're taking this, the difference here, 2467, I think. Yeah, like 24 to get to 700. 67. And let's see what we got. We got 0.75 times 67. 50.25 is what you're tacking on there. Okay. 50.25 onto the 12 spot. That's 676 plus 50.25, 75th percentile. And here we go. Let's add them together, guys, and get it there, I guess. 700, right. Yeah, right. 726.25. And that's that. $726.25. 726.25. Okay. We're done. That's it, guys. That's the course. Know these films and you know the course for Math 107. Always come see me when necessary, guys, if you're in my class, okay? We appreciate it. We appreciate all the hard work that the students are doing. This should help you get through the major portion of Math 107. Good luck to you.